All right, let's work on 1-6, day 3, single and double absolute value equations. This is some fun stuff, guys. But remember, this is that stuff that we're talking about for absolute value equations where you must use the format that we're giving you, okay? We're calling it the number line method. You've got to use that to get credit, okay? So here we go. Let's say for this one, let's just make up a couple of them. Some of these maybe we'll only set up also. So for this first one, let's just do a review. Let's do the absolute value of x plus 4 equals 8. Okay, no matter how easy you think that is, you've got to use the number line method, okay, to get credit. So here's what you should be thinking. 1, we're going to draw our whole number line. That's what the arrows are for. You know the absolute value looks like a V. So we'll go ahead and draw it. You know the vertex of the absolute value is going to be at -4 because you take the x plus 4, what's inside the absolute value, set it equal to 0, and solve. Okay, so now you're going to separate this into 2 different parts. The equations you need up top for the piecewise function are going to be as follows. So you get either x plus 4 or the opposite of x plus 4. If you think about putting y equals in front of those, then y equals x plus 4 would be the line with the positive slope. Okay, again, nothing to memorize. It's about thinking about the slope. And the y equals the opposite of x plus 4. Well, if you distribute that, it would be y equals -x minus 4, and -x would be a -1 slope. So those are in the appropriate parts. And now you replace this original equation up here, okay, this original equation, in exactly the order as it appears. To the left of -4, replace it with what's to the left on the V, and to the right, replace it with what's on the right. Okay, so here we go. You'll have the opposite of x plus 4 equals 8, and on the right side, you'll have x plus 4 equals 8. Solve each one separately. -x minus 4 equals 8. So maybe I will just manipulate it to the other side and just say -12 equals x. Okay, we'll leave it there until we check it. And on this one, we'd have x equals 4. Okay, then our quick check, remember, is asking ourselves those correct questions. So is x equals -12? Does it lie in this region? So does -12 on a number line fall to the left of -4? And yes, it does. So x equals -12 is one of our answers. And then does x equals 4 lie in this region to the right? Okay, is 4 to the right of -4 on a number line? And it is. So both of those, that's taking care of our check step. Both of those work. Okay, so we're set with both of those. All right, so let's see then what you would do with this. So I'm not even going to give you an equation. Let's just say I just wanted you to set this up. So set up your number line method, okay, for me. Everything that you know you're required. So turn off the video, try it yourself. All right, so here you go. For the number line method, 1, you get out of your number line. 2, you know the absolute value is a V. So I should see that drawn. The V goes on forever, hence the arrows. And then hopefully you said that that critical point would be 2. Okay, set 2 minus x equal to 0, solve, you get x is 2. And then let's see how you did with your equations that you're required to have in the picture. This time it would be the opposite of 2 minus x on this side. Why? Because you thought about it logically, right? If you distribute that and put it in a different order, that would be y equals x minus 2. That would be y equals x minus 2. That's a slope of 1. Yep, that side is the positive slope. And on this side, you would have the 2 minus x, because that would be y equals negative x plus 2, and that would be a -1 slope. So again, that's what we're talking about. Logically think through those guys. Don't just memorize something. Okay? And then you would go about it exactly the same way. Okay, as we just did one. All right, so then let's get into double absolute values. Okay, so 3. Let's do the absolute value of x minus 3 plus the absolute value of x plus 4 equals 7. Okay, so 2 critical points, if you will, right? You're still doing that same thing. X minus 3 would equal 0 at 3, and x plus 4 would equal 0 at -4. So you draw your number line. Don't try to do this in too little of a space. You'll run out of room, and I guarantee you it happens to me every time. I'll run out of room up here also, okay? But that's just because I'm trying to fit a lot. But we said -4 and 3 were our numbers, so definitely on a number line, we want the -4 to be to the left of the 3. Okay. And what I want to start doing now, so that it will help us, guys, with these tougher ones, is let's go back and add one step to problems that are more simple, like problem 1. So you're going to see me not only from here on out, not only check the regions on the left and the right, but you're going to see me check the critical point. Okay, it'll help us when we start changing these things to get harder. So the first thing I'm checking is the -4. So if I plug -4 in, does it give me a true or false statement? So back into the original, if I plug in -4 plus 4, I get 0. The absolute value of 0 is 0. Is 0 equal to 8? No, which means this is not a solution. If it is not a solution, and I do not want to include it, then I would put a big open circle there. If I wanted to include it, I would have filled that in. Okay, so what we're going towards is like our parentheses and brackets, or our soft brackets and hard brackets, whatever you want to call them. So start thinking about that and adding that as part of it. Okay, so here, the first thing I'm going to do is go ahead and put in our V's. Okay, so our V at -4, put in our V at 3. I'm going to go ahead and test -4 real quick so I don't forget it. So if I test -4 into the original equation, -4 minus 3, right? So -7, put in the -4 plus the 4, 0. Absolute value of -7 is 7. 7 does equal 7. That's a good answer. So I'm going to fill that in. That's going to be part of one of my answers. Do the same thing with 3. 3 minus 3 is 0. 3 plus 4 is 7. So I'm really looking at absolute value of 7 equals 7. Yes, it does. I like that answer, so I'm going to fill that in also. Okay. Now let's get our equations. Okay, nothing changed. So on the -4, I'm looking at this guy, right? So I'm either going to get y equals x plus 4, that is the positive slope, or y equals the opposite of x plus 4, that would be the negative slope. When I'm looking at this one for the next v, y equals x minus 3 would be the positive slope, and y equals the opposite of x minus 3 would be the negative slope. And now what we have created, if you put your lines in here, is we have created 3 regions we need to worry about. Okay. So let's go off to the side to try to explain to you what you do. Okay, so I don't mess up this part that we've already written. So the one thing you keep hearing me say is that when you rewrite this equation up here at the top, it's important that you do it in exactly the same order. So you want to deal with the absolute value of x minus 3 before you deal with the absolute value of the x plus 4, before you write the equals and the 7. Okay, and that'll mostly be important when you have subtraction signs between things. Okay, but my rule is just always replace it in exactly the same order. So let's see if we can do a little bit of color coding and explain this over here on the right. So let's take a moment and just do a quick sketch of this again, okay, without specific numbers. So just get two V's in here. We know that we want to be able to have these lines here and have our three regions. So here we go with just some color coding, see if this will help you out. It means now you will, on the left-hand side, right, because we're clear to the left of the number line over here, in this left-hand region, you will replace the absolute values with what is sitting on the left side of this V and the left side of this V. So you'll use those to replace the absolute values. Okay. If you're on the right side, completely to the right of this picture, well, you probably guessed it. You're going to use what's on the right side of this V and the right side of this V. And you will use both of those to replace what's happening in this section. And last but not least, when you're in between the left and the right, so I'll just put between, then you will use these parts, which are between the two V's. Okay, you'll use both of those in the middle. Okay, again, remember to replace them in the order that they were originally written in the original problem. Okay, so let's see what we can do. We'll keep that graphic up there and get rid of that maybe later. So here we go. On the left side, I'll go clear to the left, what we had in red over there. Then I'm going to replace the absolute value of x minus 3 at the top, remember in order, with what's to the left of the absolute value that includes it. Okay, so I'm going to say the opposite of x minus 3 plus, replace the absolute value of x plus 4. Well, what's on the left is the opposite of x plus 4. And I run out of room because I'm trying to show you every single step. Equals 7. Whew, just made it. Okay. All right. In the middle, I should be using the two middle expressions, but I want to do it in the order that it was given to me. So back to the original problem. The absolute value of x minus 3 is what you deal with first, is going to be replaced with the opposite of x minus 3. Plus, the absolute value of x plus 4 is going to be replaced with x plus 4 equals 7. Ooh, just fit that too. All right, and clear to the right, the one we have in blue, right? Everything on the right, replacing it in order. So the absolute value of x minus 3 is being replaced with x minus 3. Plus the absolute value of x plus 4 is being replaced with what's on the right of that v, so x plus 4 equals 7. All right, if you get through that part, you've done this procedure. And now let's go ahead and simplify each of these, or solve each of these, I should say. So go for that. Negative x plus 3 minus x minus 4 equals 7. Negative 2x minus 1. Looks like I will get x equals negative 4. Remember, we'll leave that to check in a few minutes. And now, distribute the negative in the middle. Negative x plus 3. So it looks like my x's drop out and I get 7 equals 7. Okay, which is a true statement. So if the variables drop out, you're either going to get a true or a false statement. We'll come back to that, okay, and see what that means to us. We know that a true statement, though, is supposed to mean all real numbers, and a false statement is supposed to mean no solution. So maybe I'll at least write the all real number part in here. Okay. All right, on the right, x plus 1 equals 7. Looks like I will get x equals 3. Okay, perfect. So give us a little more room here. And now we're ready to do some checking. And I do my checking a lot on my number line above. Because notice, I already have said -4 and 3 are part of our answer. Okay, so now is, on the left, checking here, is x equals -4 in this region? Ooh, well, I notice -4 isn't to the left of -4, but it is right there on that border. Okay, well, I've already verified it. That was my big red circle at the start. Big red filled in circle at the start. So x equals -4, we've taken care of that. If I were to check this part right here, does x equal 3 lie in this region? Ooh, again, it's right on that border. And I did already take care of it by filling in the x equals 3. So now it's really checking this part that we need to talk about. Okay, so checking that middle part, when it says all real numbers, it means all real numbers in this region work. If it was a no solution, it would say no real numbers in this region work. But again, it's about in this region, meaning between -4 and 3. So if I just graphically write what this means, all real numbers in this region between -4 and 3 up here on my number line, that would mean I'd be filling that in. Okay, and we're used to doing that. That means we're going to have an interval. So not only do just -4 and 3 work, but anything in between them. So you would be telling me a final answer of x equals, just so I know you know it's an interval and not like an ordered pair. Well, if I can equal -4, it's got to be a bracket. And anything from -4 to 3, again with a bracket, works. So notice we're going to start getting some intervals. Okay. Remember, you've got to use this method. The beauty of using this method is what that just did for you, right? You didn't have to go back and plug in every single number. You'd be there for a long time trying to verify every number between -4 and 3. In fact, you'd be there infinitely. But what that did is that took one out the possibility of something that doesn't work. Because think about it, guys. Your first absolute value here could be positive or negative. And this one could be positive or negative. So we'd be telling you that you would have to check the negative with the negative, the positive with the positive, the first negative with the second positive, and the first positive with the second negative. That's 4 possibilities. Well, look what we ended up with. We ended up with only 3 regions. That means we threw out the possibility that didn't work ever. Okay, so why bother checking it? This actually makes it a lot shorter. And then just testing your regions checks your other 3 for you. So there is actually a big benefit to using this method, okay, that we require of you. Like I said, in all of our classes here at Creek. So use that number line method, get it down, okay, and I think you will learn to love it. It will make your life a whole lot simpler when you are trying to check things. Okay, all right, go for it.